Hyperconverged Infrastructure, or HCI, is, as some might say, the buzziest of buzzwords. Okay, maybe not the buzziest, looking at you, IoT, but for those who are used to traditional three-tier architecture of servers, storage and networking, it's pretty revolutionary. Hyperconverged infrastructure is essentially a single box that you can plug in, switch it on, and, in theory anyway, you're off. But don't let the simplicity fool you.
To look at hyperconverged infrastructure, I think you have to go back to the roots of what is infrastructure in an organisation.
That's Matt Harris.
I am Vice President of Hybrid IT for Hewlett-Packard Enterprise.
With the help of Matt and the rest of today's guests, we're going to be untangling the hyperconverged story from mainframes to disaggregation, whatever that means. In order to answer some of those burning questions, is HCI the right solution for every organisation? How can you move to hyperconverged when you've spent a bucket load of money on new servers? And what has the trackside team at the Aston Martin Red Bull Racing Formula 1 team got in common with small independent retail stores? All of this and a bucket load more. I'm Michael Bird, and this is Technology Untangled. Now, on this show, before we dive too much into the topic, we like to take a brief look back as to where we've come from. So it's time, as always, for a little history. The birth of modern computing really started in the 1950s when IBM innovated the mainframe. Here's Luke Peters, a hyperconverged infrastructure specialist at HPE, with more.
If you ever Google mainframes from the 50s, you'll see these gigantic machines taking up acres of floor space in some big factory units. And they were huge. They were very complex and incredibly expensive as well, so quite a niche market. If you move into the 60s, we started to see mini computers, which were smaller, cheaper versions of mainframes and a little bit more accessible as well to businesses rather than very, very high-end organizations. Moving into the 70s, we start to see the IBM System 360s, Apple II, Commodore PETs, Tandy, just to name a few, and it really starts growing into that market space. And then you kind of move into the 80s and 90s where we start to see the technology evolve further into workstations and servers. From there onwards, you've got all these separate servers with direct attached storage running a single application. Well, that's quite a waste of resource because that one application might only be consuming 10-15% of what's available and it cannot be shared. We start seeing SAN being introduced, so storage area networks. You know what, let's share all of this storage across all these different servers and we'll get some incredible efficiency. We can share storage across all of these servers. How do we share the compute across them? And then we start seeing virtualization. And the main one that people will recognize is obviously VMware. It starts virtualizing the compute, and now you can run multiple workloads on a single server with shared storage. And that's what we see today as kind of a common three-tiered architecture. So the top layer being compute or your servers, and at the advent of sort of the early 2000s, they're going to be your HPs, your Dells, your Fujitsus. You then got your storage layer, and these can be your EMCs or your NetApps, and then you got your fabric switches which connect your compute to your storage, like Brocade, for example, would be an obvious choice for that. And obviously the inherent problem here is that whilst it's a best of breed approach, you also have 3 different vendors potentially running this infrastructure. So when you have a problem, who's it you call? So you have different management layers, you have different support contracts, you have different OPEX and CAPEX costs associated. If you want to upgrade the storage processor, how does it impact the storage switches, the servers, the virtualization layer? It all consumes a lot of time, and that's typically the biggest problem with three-tiered architectures, the amount of time it consumes just to run them, just to feed and water, patch and update and maintain.
The market needed something different, and that is where converged infrastructure comes in. It included the same things you'd find in your traditional three-tier architecture, like servers, storage, and networking, but it was brought to market by vendors collaborating to create racks of integrated components. A prime example is 2009's vBlock, which combined EMC's symmetric storage and Cisco's compute and switches alongside VMware's vSphere server virtualization.
So VMware, Cisco, EMC joins together to form a company called VCE. They would basically build the infrastructure. So they'd take your three-tiered architecture today, so your servers, your fabric switches, and your storage. They would take those, put it into a rack for you, cable it up, make sure it's configured to a set reference architecture, deliver it to the customer. So the customer's not having to go and buy separate components from different vendors, put them together in a rack, cable them up, power it on, get it all configured. That's all taken care for you. That's already been done.
That was a huge win for organisations. Three-tier architecture could take months to be properly set up, configured and working perfectly. But with converged infrastructure, performance was there from day one.
I guess the innovation that happened 15 years ago with converged infrastructure gave organizations a business benefit, which was to deploy more quickly, for the integration of those technologies into a single rack to be done prior to the solution being delivered to site.
It kind of auto-configured itself after a few hours and away you go. And the time to market was fantastic. But beyond that, it didn't really address any of the existing legacy issues of management. And then you look at scale. Scale was a big problem. So these blocks of architecture were big. And if you wanted to grow a little bit, maybe 5%, maybe 10%, you couldn't really do that. You had to buy another massive block of architecture.
The challenge with converged infrastructure is multiple management platforms, the ongoing management, the integration requirement, the skill level needed of personnel in your organization to continue to monitor and manage and optimize that became really complex, and systems became complex.
Now, despite the gains of converged infrastructure, managing it was a total time and energy suck for organisations. And that meant the data centre was still very much ripe for innovation. Enter hyperconverged infrastructure, pioneered and popularised by Nutanix and SimpliVity in 2012 and 2013.
Hyperconverged infrastructure, or HCI as we call it commonly, seamlessly combines these different components like compute, storage, networking, as well as a virtualization layer with the different hypervisors and the data services, all in a single physical system.
That's Bageshri Kundu, Global Strategic Product Manager for HPE SimpliVity.
So the HCI software stack, currently, they run on industry standard x86 servers, and those are running virtualized, or even nowadays you can see them running kind of virtual container workloads as well.
You have a single management platform, which therefore takes out complexity. It means that from a hyperconverged perspective, you can have a single administrator who is responsible for the entire stack. You also have an ability to scale in what we call node format. So very skilled and small building blocks to grow.
All right, so that's the end of the history lesson. Converged delivered the three tiers of architecture as an integrated stack, and hyperconverged wrapped all of those with a software layer, simplified, plumbed in, and without the need for mass configuration. This is what IT departments worldwide had been waiting for.
The key benefits of HCI from an IT perspective, I think number one is manageability of the environment. Streamlining the management, having a single generalist is going to save the organization a lot of time that can be spent elsewhere. Most hyperconverged platforms run upon a VMware environment, so vSphere, for example. If you know VMware, you're already 90% familiar with the platform that you're about to invest in. So it's a very, very quick learning curve.
So another big plus around HCI is scalability. Yes, HCI is a box, but don't let its dimensions fool you. Hyperconverged is what's known as a block-based architecture, and so it can be scaled piece by piece, node by node, which means organisations can start small with, say, a single box And they don't need to do a massive architecture design for one project. They can basically scale it out one block or one box at a time.
Customers are looking to have scalability in line with how their business scales. So not having to over provision or buy too much architecture, which isn't the right requirement for what their needs are.
If you just need a little bit more resource, you can scale by just procuring an additional node. And then that node can be deployed into your environment non-disruptively, no downtime to the rest of the environment. It just gets deployed, it assimilates, it configures itself, and away you go.
One of the key features of HCI is software-defined storage. IT departments have to manage and store an astronomical amount of data, so efficiency is absolutely vital.
You look at your three-tiered architecture, you would update your servers independently from your storage, from your fabric switches, and any other software that you have in your environment. That's quite time consuming. Lifecycle management for me is the ability, almost like a one-click upgrade. In fact, it is a one-click upgrade where you can upgrade that hyperconverged node and update all of the components that are associated with it.
Thanks to its manageability, its scalability, its lifecycle management and quick learning curve, HCI is a pretty neat solution, particularly if you've got a distributed workforce.
We've seen customers deploy hyperconverged infrastructures in remote sites where they can't have skilled management or labor resources to manage the infrastructure.
Regardless of how widespread the physical resources happen to be, hyperconverged systems can handle them as though they were all sitting next to one another. So it provides a true flexibility where you can actually scale up or scale down resources on demand.
Hyperconverged offers portable infrastructure on demand. And who better to talk to us than somebody who literally ships a data center around the world to some of the most un-data center friendly environments, Formula One race circuits.
We're shutting down a complete data center 35 times a year. So yeah, it was just pretty insane really when you think that, the average data center probably doesn't get shut down once every 5 years unless it's for some form of electrical testing.
That is Chris Middleton.
My name is Chris Middleton. I am the Head of IT Infrastructure Operations at Aston Martin Red Bull Racing.
This is Hyperconverged Infrastructure in the fast lane, where time is of the essence, performance is non-negotiable, and the environmental conditions are challenging to say the least.
In Bahrain, it's 40 degrees. With Singapore, our server is going to be dripping wet with humidity and shutting themselves down.
The trackside team have certainly got their work cut out for them.
It's pretty hectic. Traditionally, on Monday they fly into the locations. They'll nip into the track, just make sure that all of the freight has been delivered. Tuesday is unpacking. The garages are in a state where they can just roll the freight into them. Racks are unpacked and everything's kind of cabled up. And then Wednesday, Thursday is set up and pre-checks, system checks, making sure that everything's come together in the correct order, servers are up, status is green, no hardware failures, etc., etc. Thursday is the day that most of the engineers are rocking up to the track. Essentially, engineers are our customers. We need to make sure that we are set up ready for them to start working. If they can't work, it means that we're delaying the setup and config of the car. So Thursday we need to be almost 100% there. Friday, double practice. We enforce change freeze as of Friday night, so there's no more uncertainties or adventure or anything like that. Practice 3 on the Saturday morning, and then you're into the sharp end of the weekend and the qualifying. And then Sunday obviously race day. And then pack down.
During practice, qualifying and the race, the data centre and infrastructure are pushed to their limits in terms of consumption. But what goes up must come down, and for the team, it's got to happen fast, especially if there's a race the next weekend.
A race traditionally starts at 2 or 3 o'clock, lasts, let's say, 2 hours, so we're at 5 o'clock, and then the analysis of all that data then gets done by engineers at the track and engineers in the factory. You've got your mobile data centre, which is up and alive while everything is being packed down around it. There will be a final call from the engineers saying, right, we need to get this shipped and sent, and then it's a rush to get the equipment shut down and the data centre shut down as quickly as possible without causing any corruption to that data. We can now shut down that infrastructure. I say an hour, but I know that they can do it in 30 minutes now.
That impressive 30-minute infrastructure breakdown is thanks to the star of the show, Hyperconverged Infrastructure, in this case, HP SimpliVity. Everything the Aston Martin Red Bull racing team need to do is at the extreme. But their drivers for using HCI are universal: reliability, simplicity, agility, and flexibility. But for them, it's just cranked up to 11.
Trackside infrastructure is so complex, there's many things that we need to consider. I think the main thing that we're looking at is reliability. If we've got any questions on its integrity or its stability, that could be the difference between us actually, completing a race or having data for a lap or 2 laps or anything like that. Next, I'd say we're looking at performance. So, Formula One is a performance sport, and we're always looking to squeeze out the droplets of what we can for performance. So we've got to make sure that we need to be, every iteration of our infrastructure needs to be faster than the last. We need to be getting more storage, quicker CPUs, more memory, so we can throw more resource at any given problem. And if we can throw more resource, therefore we can run more iterations of a query or a strategy or a car setup. So the more scenarios we can test, the more chance we have of hitting that sweet spot for the setup, and therefore the greater the performance of the car. And then lastly, I think the other, which we kind of overlook, and it's agility. How F1 is a really quick changing, fast-paced sport, and we make our budget requirements, or we initially invest in a solution for around 3 years. And looking into how the sport changes, the regulations change, etc. 3 years in technology is a long time. So we've got to put a big investment into an infrastructure and a platform that's got to last 3 years without really knowing how the rules of the sport are going to change. We need something that we're able to shift workloads around and make fundamental changes. It might be that we need more VDIs, it might be that we need less application servers and we need to be doing more GPU-based querying, all that kind of stuff. So we need something that we're able to very, very quickly reallocate resources without spending thousands and thousands of pounds, and quickly to be able to meet these needs of the business. F1's a very odd sport as well, where growth rates aren't necessarily linear. One of the designers or engineers or developers may come up with a fantastic idea that suddenly requires, triple the amount of resources that they did previously. But if it has a positive effect on car performance, then whatever it takes to make that car performance.
The ability to reallocate resources when using HCI is directly linked to competitive performance. And as Matt explains, the benefit really applies to any organisation.
This day and age, time to market of new applications, new products that customers are trying to bring to market really does differentiate and give organizations benefit versus their competitors. So speed of deployment becomes critical, and hyperconverged infrastructure, because of the simplicity of it, because of the building block nature of it, means that test and development cycles on applications can be faster. It means that organizations can bring new products or applications to market more quickly without having to have invested significantly in an architecture where maybe some of those applications or products they're bringing to market aren't going to pass the threshold or the test of market acceptance. So the business benefits relate around significant cost reduction, simplicity of management by a single person, which gives operational benefit in terms of speed, an ability to bring products and solutions and applications to market far more quickly.
As tech rapidly evolves, IT departments are pushed to constantly adapt and often to actually do more with less.
we want you to run these workloads, or we want you to run this type of environment, or add more workloads to the environment, but we're not extending the amount of staff you have in the IT team. Just do more. So having that ability to reduce the amount of time managing the infrastructure frees them up to actually go and investigate these new applications is very important to the business. They don't want to have to worry about the infrastructure. It should just run.
I no longer need a network specialist, a storage specialist, a server specialist, a virtual guy. My servers and the storage, it's all just rolled into one. And it's that tight interaction between the two means that we're just a lot faster, a lot more tightly knit, and we don't require that same level of highly skilled resource.
Aston Martin Rebel Racing is the extreme on the spectrum of HCI use cases. But as Bageshri explains, moving from legacy three-tier infrastructure to HCI can benefit just about any organisation.
So this retail chain runs 24 hours a day, 7 days a week. So during the day, the retail storefronts are open for customers, and during the night, their warehouses and logistic operations continue to operate. This particular retail chain needed at least 4 IT experts to maintain the legacy infrastructure. So doing maintenance on these systems was a horrible experience, right? They decided to try out HCI due to the flexibility and the simplicity of the solution that it provides. So they run thousands of concurrent kind of virtual desktop sessions on it for the remote workers. They also run ERP and business continuity applications and critical warehouse applications on virtual machines on top of these HCI systems. And the performance has improved multiple fold. It's a significant jump in their performance, even with a significant load on the system, right? So backing up their VMs now just takes a few seconds, and restoring these backups, they probably do it like once a month, makes this a seamless process with absolutely no downtime. All this infrastructure can be managed with a single IT resource. And as the business continues to expand, they are able to easily scale their infrastructure to support their growing needs.
Because it's so easy to scale, a lot of organisations have jumped on board with HCI, particularly those who run a large amount of virtual machines. And with the unprecedented events of 2020, organisations that were already using Hyperconverged actually saw some of the benefits of that choice in real time.
We have also seen specific use cases such as virtual desktop infrastructure, which has seen massive scaling requirements, particularly since the COVID-19 crisis that we're all experiencing. And as customers want to deploy virtual desktop infrastructure, or VDI as it's known, they're looking for a far more simpler, cut down version of how they can do that effectively in their data centers, one which allows for immediate scalability when more workers or users require a VDI-based experience.
It is super easy to actually deploy new clusters and spin up virtual machines in an extremely short time. HCI also provides a true resiliency and security for these virtual machines. The new virtualized solutions can also be easily accessed and managed virtually to power up a range of kind of remote applications in the market segments. Mostly, I would say banking applications, electronic trading, telemedicine is a big one today. Supporting remote workers in a temporary kind of medical facilities, and also e-learning, right? Where our universities and schools have not been open for a significant amount of time. And remote learning is a very important part of that. So the remote support capabilities that hyperconverged VDI solutions that provide, they have been, I would say, very essential to customers.
Now, if you're not looking at HCI, as an organization, you're not really doing your job, because that is a de facto standard now for data centers.
We're starting to see organizations invest in hyperconverged infrastructure for other use cases, and that could be around data center modernization, enterprise scale applications, database, file and print. So I would say no application is really off the table for a consideration of moving to hyperconverged infrastructure, given the innovations coming out today from HP and other vendors.
For high-octane enterprise IT solutions, HCI ticks most of the boxes. But what about smaller organisations? Well, there is beauty in HCI simplicity. And for small and medium businesses, it can be a perfect all-in-one hassle-free solution.
For folks who are not really or familiar with IT, if they actually start looking at traditional, legacy infrastructure, right, it can be quite daunting at times. And then if they start kind of digging into hyperconverged, they will see that right up front that the simplicity and the ease, it's kind of a no-brainer for those mom and pop kind of shops or small kind of retail stores, small gas stations where the IT needs are very small. The customer does not have a lot of IT expertise or a lot of IT skills, but the organization wants to kind of modernize their IT infrastructure, right? They want to start with something small, and they may not really have that larger growth that we see with other enterprise kind of applications. So Hyperconverged kind of builds that need very well. These businesses can actually go live overnight. They just need to deploy the small cluster of nodes. They don't have to worry about other appliances like backups, and everything can be managed. That whole data stays within their data center, stays within their retail stores. And I think that's a big plus.
Small and medium businesses can plug in and get going right away. But the question remains for organisations at scale. How on earth do you implement when you've already paid a lot for the kit that you've got in place?
Organisations no longer need to rip and replace. It's clearly an option where organisations may look at a new modernised platform for the future. But organisations may want to leverage investments they've made previously. What we're seeing is a number of hyperconverged vendors really innovate in that field. An example of that is we have a number of organizations who have made compute purchases at the server layer over the last 2 years, and they're attempting to move to a hyperconverged infrastructure given all the business benefit out a platform called disaggregated hyperconverged infrastructure, where organizations are able to utilize the server investment they've made previously and bring in the other areas and of storage, network, and the management area to convert their pre-existing investments.
Whoa. Disaggregated hyperconverged infrastructure? I thought the whole point of HCI was to have everything together in one box.
It's bringing all the benefits of a hyperconverged solution, but taking away a number of the restrictions organizations have shared with us of why they haven't moved to those architectures. So DHCI has independent scaling of compute and storage layers. It has a single management interface, which is today based on VMware. It has artificial intelligence embedded within it, which is monitoring and maintaining that infrastructure without human intervention.
So despite sounding like an oxymoron, disaggregated hyperconverged infrastructure almost seems like a logical next step. By incorporating AI, it will potentially open up a new world of efficiency and speed.
For the last 3 to 5 years, we've seen organizations really drive a cloud-first strategy. And that has been driven out of necessity where costs were too much, speed was of the essence, and time to market on products and solution was required. The trend that we're seeing now is that cloud-first only strategy isn't fit for purpose and a one size doesn't fit all. There is certainly an understanding with organization analysts and vendors out there that a hybrid approach to infrastructure and workloads will play a prevalent role in the future.
So clearly, this isn't the end of infrastructure's evolution, and we're probably going to see some big changes in the future. HCI is more about how a system looks from the outside. It's a simplified box giving you the entire stack. We want it to look integrated from the outside, but what's in the box is totally open for discussion. DHCI is very much a continuation of that story, offering additional flexibility and capabilities that place it at the cutting edge of infrastructure.
DHCI and hyperconverged infrastructures classically address some of the enterprise data center needs, but the future of on-premise data centers will also span to what we call the edge. And you think about technologies such as IoT and 5G, organizations will start to reimagine what on-premise infrastructure means. We'll see organizations look at oil rigs and deep sea and the rainforest in a way that was never been done before or been possible before, and remote regions that can't classically be accessed or maintained will require technologies which have AI at its core, where they self-manage and self-heal and can collect that data and insight to give business advantage or to solve world problems in the future. So I think, who knows, from a tech innovation perspective, we know AI will be at the heart of it. And I think you'll also see commercial innovation ramp and continue to be a major theme, or a more important theme, moving forward.
HCI and DHCI are working towards the challenges IT departments are facing now and in the future that involve massive amounts of data and the need for agility, stability, and speed. You have been listening to Technology Untangled, and a huge thanks to today's guests for joining us: Luke Peters, Matt Harris, Bageshri Kundu, and Chris Middleton. And you can find more information on today's episode in the show notes. Make sure to hit subscribe and give us a rating in your podcast app, and join us next time when we'll be looking at containers, the what, the why, and the how of this small but mighty piece of technology. Today's show was written and produced by Isabel Pollard and was hosted by me, Michael Bird, with sound design and editing by Alex Bennett and production support from Harry Morton, Thomas Berry and Alex Podmore. Technology Untangled is a Lower Street production for Hewlett Packard Enterprise in the UK and Ireland. Thanks for tuning in, and we'll see you next time.